low voltage compartment or the LV box is the brain of any switchgear. Let it be the medium voltage, low voltage, or even the high voltage. And if something is wrong there, if you don't understand what is inside it, you're missing out on a lot of things. If something goes wrong, even if you have the most expensive circuit breaker, it won't work, because that's the brain, right? And in this video, I'm going to give you all the details about the low voltage box inside the MV switchgear. What are all the component it has? What is the function of that? And in the end, we'll also look at the actual LV box. So make sure you watch the video till the end. Now, first, let's start with the basics. It is equally important that you understand why do we call it as a low voltage box, even if we use it for high voltage or medium voltage system, right? So that's the fundamental question. Let's address that. So imagine we have a 36 kilovolt medium voltage switchgear panel. Now, of course, all across this panel, the operating voltage or the rated voltage would be 36 kilovolts. So including the cable compartment, of course, the cable that will be entering will have 36 kilovolt. So that is present here. There will be circuit breaker chamber. There also 36 kV will be present for sure. And the circuit breaker will also be rated for 36 kilovolt. Then there will be bus bar compartment that will also be rated for 36 kilovolt. But then comes a compartment which does not operate on 36 kV at all. It operates on maybe, let's say, 110 volt DC, 220 volt DC, 48 volt DC. And that compartment is what we refer to as low voltage compartment. And that is also the reason why it is called as the low voltage compartment, or sometimes people also refer it as the metering and relay chamber. They operate on much lower value, almost all the cases less than 1000 volts, right? So the operating voltage, the control voltage may vary based on project to project, customer to customer, but general ratings you can consider 110 volt DC, 220 volt DC, 48 volt DC. Now I've done a dedicated video where I explain why the low voltage compartment only operates on the DC supply. So if you're interested, you can definitely check that out. So that is the reason it is called as low voltage compartment, because it works on low voltage supply only. Why is that? Because the equipment that we are going to use inside that box cannot accept the high voltage coming out from the cables. For example, this 36 kilovolt panel, you cannot have a 36 kilovolt meter. You cannot have a 36 kilovolt relay. And if you somehow develop that 36 kilovolt relay, it will be huge, right? You need almost this amount of space to accommodate only relays and meters, indication lamps and things like that, right? So to avoid that everything, what we do is we step down the voltage, we step down the current in with the help of instrument transformer, and then use it in the low voltage compartment, right? So that is the reason why it needs low voltage. It cannot operate on the rated voltage of the system. Clear? Now the next question comes, where this low voltage compartment or low voltage box is placed inside the switchgear. Now there are multiple locations. Most commonly, if you're looking at the low voltage switchgear or the medium voltage switchgear, you will find them located on top of the switchgear, where all the indications relays are accessible to the maintenance stuff. One example you can see on your screen. On the ring main units also they will be there. So you can see on top of this ring main unit, the complete low voltage devices, compartment indications are provided. And this is a extra high voltage gas insulated type switchgear. I'm not sure exactly is it 245 kV or 420 kV, but you can see this is a low voltage compartment. It will have HMIs. It can also have indications and all the other things, basically all the things that you can control from this, right? So that's the low voltage compartment. And not necessarily it will always be on the top. I've seen the panels where both sides it is provided. So you see top, we have the low voltage compartment, and also at the bottom we have the compartment. Now I want you to remember one thing, that there is no standard design when it comes to the low voltage box or low voltage compartment. It will change based on the project's requirement. It will change based on the manufacturer design, and it will for sure change what kind of protection, what kind of indications you want. So most of the cases, the low voltage compartment will be different from one customer to another customer, one manufacturer to another manufacturer. In fact, even different for one project to another project, even if the customer is same, right? So this may change basically. So there is no standard rule or thumb rule that the low voltage compartment will look like this. Low voltage compartment will have only this type of equipment. There is no as such limitation on that. But in this video, I'll try to give you some of the common components that you find on the low voltage components, right? So that's the location of the low voltage compartment. Now the question is, how do we get the supply here? So first, the most important thing is auxiliary power supply. So we talked about this, right? So 110 volt DC, 220 volt DC, that is auxiliary power supply, and that will be there inside the site or on the site. So there will be maybe a battery bank or maybe a dedicated auxiliary transformer which is stepping down the voltage, getting converted into a DC if it's working on DC, and then all the things are fed from auxiliary power supplies, indication lamps, relays, and things like that, right? That's one input for the low voltage box. The second input is the current transformer. So we can also have relays which operates based on the value of current. There will be meters. So to all that, current transformer is the input. Now current transformer can accept, let's say, 800 ampere coming from the incoming. That 800 ampere will be stepped down to, let's say, 1 ampere, and then that 1 ampere goes inside the meter, and then meter gives us the reading, right? That's the second source. Third source is the voltage transformer. Same like the current transformer case, we have voltmeters, we have protection specific to voltage. So all those things are fed by voltage transformer. So voltage transformer will take, let's say, 36 kilovolt, step it down to 110 volt by root 3 or 220 volt by root 3, and then it will fed to the relays and meter that we have here. So these are, you can say, three source of supply for our low voltage compartment, and that's why CTs and PTs are used inside the switchgear panels, right? Now let us have a look at some of the common things that you will find on the low voltage compartment. So the first and the most common things that you will find are the indication lamp. Now these are small lamps, but very, very useful to indicate the status of different things. Some example, you can see circuit breaker on, circuit breaker off, circuit breaker trip, circuit breaker is in service. So you'll get an indication on top. Spring charge status, of course, for the circuit breaker, if spring is charged or not, that indication you will get. Trip circuit healthy, that indication you will get, and maybe even some of the fault indications can be provided with the indication lamp. Right now, please note, these are the list that I've mentioned on the screen. It's not limited to that. It's just examples. There can be a long list of indications that can have maybe 10, 20 indications on the panel. It's possible. So that's the one thing you have to remember. This is not the limitation. Okay, these are just a few examples. Now the next question comes is, how do we get these indications? Let's take example of circuit breaker. Now circuit breaker will have auxiliary switch. Now it changes the position of its contact based on the circuit breaker position. If circuit breaker is on, let's say a few contacts will be in on condition. The moment circuit breaker closes, this on or the open contacts will close. The moment it closes, we can have the indication here. So we don't give 36 kV here again. So we work based on the auxiliary switch and the auxiliary supply that we are having inside the switchgear, right? So indication lamps, very useful things to indicate the status. Then you will also find annunciators. Now these are a few examples. You can see we have one on the left, one on the right. And this, again, there is no standard thing here. You can choose what type of window that you want. So this one indication, the one red portion, is what we call as a window. And that each window can have a separate indication of abnormal conditions. It can be of 3 or 4 windows or up to 50, 60 windows. So depending on what application you are using and what kind of indications you want. Now here, a very common question comes is, what is the difference between indication lamps and the annunciators? Both are giving indications, right? The thing is, You can consider it as like this. Indication lamps, you can say, are used to indicate the status: breaker on, off, close, trip, spring is charged or not charged. So those are like status of the things, and that is provided by the simple indication lamps. Annunciator, on the other hand, are specifically used to indicate abnormal conditions, faulty conditions: earth fault, short circuit, maybe phase to ground fault, the circuit is not healthy, and things like that. So those are there to indicate the abnormal conditions. Indication lamps are there to indicate the status of the things. Annunciator for abnormal conditions, right? And I'll show you when we see the actual low voltage compartment what are options they have provided here. Now this annunciator may or may not have hooter inside it. So of course, when the abnormal condition come, that specific window will start blinking, and it may make noise. If there is no hooter provided inside, then we can have a dedicated electronic hooter which will make noise so that customer can know which panel is faulty and what kind of fault has occurred. So that specific window will start blinking when the fault is there. So that's the purpose of annunciator. Then of course you will also find meters. So you can see we can have multifunction meters, or we can have dedicated ammeters, voltmeters. Again, here you can see multifunction meter is provided. So when we say ammeter or voltmeter, they are specifically designed to give you the voltage and current. Multifunction meter can give you a lot of things, including power factor. So that is the thing, that meters you will also very commonly find on the low voltage compartment. In fact, you will also find revenue metering in some of the panels. So especially the meters that we see inside our homes, right? So that can also be provided on this panel to monitor the electrical consumption. So those are meters. Then we have selector switch. So you see all these are selector switch. With the help of this, you can select different conditions for circuit breaker disconnectors. Let us see some of the common example. The first and very commonly seen selector switch is remote or local operation. So you get two types of operation that you can perform. One, you can give a remote command from SCADA system and the circuit breaker will trip. That's what we call as remote. Or else, let's say you don't want to have remote command, you are standing right in front of the panel and you need to close the circuit breaker. So in that case, what you will do, you will turn this switch towards the local operation. The moment you turn, all the wirings will allow you to, switch off the circuit breaker using the local contacts. If it's in the remote side, you won't be able to do anything here. The circuit breaker will not trip. If you want to locally trip the breaker, you must put the handle on the local selection. Then only it will work. So this is also kind of an interlock. And commonly seen is a remote local. We talked about this. You will also see T and C switch for circuit breaker: trip, neutral, and close. So when you put it on the trip side, the breaker will trip. When it's on neutral, the breaker stays in the position it is in. And if you want to close, you put it to the close condition and the breaker will close. The same functionality we also have for disconnector and earthing switch. So those are selector switches you will commonly find on the low voltage side. And then of course, definitely relays. You will find lot of relays placed on that depending on the application. Different types of relays, electronic relays, and everything will be there. For example, you can see one relay here. It provides multiple functions. We have overcurrent, we have earth fault, sensitive earth fault, phase unbalance, thermal overload, breaker failure, condition monitoring, trip circuit failure. It's a long list, right? So you can have multiple relays also placed inside this. So those are relays. And then also you will find voltage in detection and indication system, VDIS. This is very important. You will find it on ringman units and the medium voltage switchgear, not mostly on the high and extra high voltage switchgear. So it's a safety system basically. It checks if there is a voltage on the line side. If yes, you will get indication on it. This is very important because when you want to carry out the maintenance on the, let's say, cable compartment, and if the voltage is present there, you should not do that. It's risky. So with this indication, you will get to know whether the voltage is still there or not. And once it is confirmed the voltage is not present, then you can go and carry out the maintenance. In fact, I'll just go to the previous slide to show you one VDI. So you can see this part here before the indicating lamps, this is basically the VDIS, right? This is very important, most commonly seen in the RMUs and the medium voltage switch gears. Now these are some of the common equipment components you will find on the low voltage switch gear. Now let us have a look at the actual simple compartment, low voltage compartment. So on top we have the indications, so breaker on, off, breaker trip and spring charge. So all indications will be there. It's a status only, right? And then we have multifunction meter here. It can monitor voltage, current, power factor, active power, reactive power, everything can be done using this. Then on the center we have a relay. It's a withdrawable type relay. You can remove it just like circuit breaker. In case something has gone wrong, you can just remove it and replace it with the new one. So that is provided there. Then we have annunciator here. Now on this you will have, now for this particular panel, they have provided overcurrent trip indication, earth fault trip indication, and then there are 2 windows as spare. So if I'm the customer, I can choose and decide what indication I want there, and I can wire things accordingly, right? And with that, we also have electronic hooter, which will make noise in case something goes wrong. Then first, you see there are 2 selector switch. The right one is basically the local and remote switch we talked about. When it's on the remote side, only remote operation is possible. Local is not possible. When it's on the local side, remote operation is not possible. So this also acts as an interlock. Imagine a situation, you're doing a local operation and someone also sends a command from the remote side. So there will be a chance of worst condition. So to avoid such things, this also acts as an interlock. Only one side operation is possible. So that's one selector switch. And third, the second switch is TNC switch, trip, neutral and close. Right, so you can choose whether you want to trip the breaker or you want to keep it as it is, or you want to close. Where you will turn it, the breaker will operate in that way. And then you also have a reset push button. So this is kind of master reset. So if there are some faults or maybe annunciators and everything is giving some indication, you can just press that and everything will be resetted. Now what we saw is a very basic level of low voltage compartment. There are very complex low voltage compartment as well. Again, that will be based on the requirement. And if you open the low voltage compartment, what you will see is the jungle of wire. So a lot of wires, lot of logics, and this complexity increases as you add more and more logics, more and more protection functions. So this becomes very critical and also very complex. And of course, there is cost associated with this. So the more logic you add, the more interlocks you add, the more wires you need, the more maybe MCBs you need, contactors you need. So the cost will go up with that, right? So that's the low voltage box, and it has to be low voltage because generally the maintenance staff, the engineers will go and operate with that. They will not go and touch the circuit breaker compartment. They will not go and touch the cable compartment on a regular basis, right? Or when the supply is on. But the low voltage side is something you can go and touch on a regular basis to check the indication, to set the things. And you can also do it when the supply is on. So that's why low voltage compartment is very, very important. I hope you understood what is low voltage compartment, what are the different things that we have provided inside that. If that was helpful, then do like the video, do comment what do you think about it. And I'm sure I have not covered all the things that are there on the low voltage compartment. If you think something is missing, please comment that so that everyone knows about this. All right. Please remember, if you want to learn more about the medium voltage switchgear, I do have a dedicated playlist on that. You'll get a link for it down in the description. Definitely go and check that out next. Thank you so much for watching, guys. I'll see you in the next one. But till then, keep watching, keep learning.